morning to everyone. Meralgas Corporation, a premier global one-stop shop die-casting supplier and primarily engaged in of the following processes: aluminum die-casting, precision machining, finishing and painting processes. We provide original equipment manufacturing in different industries. Awarded as Employer of the Year by People Management Association of the Philippines and received prestigious awards from different companies. Our team is headed by yours truly, Jesse Aseo, Ronald Chavez, Melanie Sandy, Kevin Sapanon, John Paul de la Cruz, Darwin Almosera, Joy Giron, Ruben Redondo, Angie Carza, and our mentor, Ms. Cristina Escolta. And we are the
Justice League!
DAS and ICE stands for Improvement for Conducive Environment. For our circle of activities, we conducted 18 meetings with 100% of attendance. And our team,
5S plus safety!
for our reason for selection, we review metal cast stock concerns from January to March 2019, and we hit our target on productivity, quality, and customer care. But not the accident having 2 incidents, and 5S plus safety having low rate of 64.98%. Reviewing the accident, already with countermeasure, and the status is closed. For 5S plus safety audit, no countermeasure yet. So this is our priority. Looking at the radar chart, finishing building got the lowest rating on 5S plus safety audit. And for the trend, from year 2017, year 2018, up to the first quarter of 2019, they're consistently not hitting the target. For the audit findings, dust is the main problem of finishing building. All our employees are at risk to inhale dust during process, also may affect the quality of parts which resulted to delay delivery. That's why we come up with a statement of the problem, 42% low rate of 5S plus safety at finishing building from January to March 2019.
For the separation of the problem, we check all finishing sections that contributes dust. Drilling section, not a contributor. Filing section, not a contributor. And we found out that sanding and polishing section is the contributor. Let me show you our sanding and polishing area. At left, sanding line. At right, polishing line. What is sanding and polishing? Sanding is a process that removes excess material, while polishing is a process that makes the product smooth. During process, heavy particles falls down to the trash bin, while light particles is being absorbed by the vacuum to prevent mixing on air. There are 3 kinds of dust being generated: sanding dust, polishing dust, which can be collected, and airborne dust, which cannot be measured. Therefore, this is our priority. During mass production, airborne dust is being absorbed by ducting. Where does it go? Airborne dust is being absorbed by centralized vacuum system and being collected by 5 cartridge filters. Dust is being separated to become filtered air. Our daily collection is 5 kilograms. Effect during production. Weight of dust collected on 5 pieces cartridge filter in 2 weeks production is 52 kilograms. We also identified that the vacuum air intake is only good for 3 days. Days 4 to 12 did not hit the required vacuum air intake, which resulted to presence of airborne dust in sanding and polishing section. To verify, we put clean filters on finishing areas. After 13 days, clean filters become dusty. Every 2 weeks, we need to clean cartridge filter to maintain vacuum efficiency. We gave an actual cleaning process and our findings. But first, operators bringing the cartridge filter to the roof without harness, unsafe act. Second, operators hitting the cartridge filter with a wooden stick can decrease tool life. And last, air blowing the cartridge filter. Oh no, this is not good for the environment. Every 2 weeks cleaning, we collected 50 kilograms of dust. Our conclusion, 50 kilograms of dust is being thrown to environment. That's why we came up to the statement of the target, proper collection and disposal of 50 kilograms of dust to improve 5S plus safety at the end of June 2019.
For the analysis of the problem using fishbone diagram, with the problem statement of 50 kilograms of dust is being thrown to the environment. Here are the probable causes. For machine, overusage of filter, and no established machine to be used for cottage filter cleaning. For man, absenteeism. For material, no available cartridge filter. For method, no study conducted for standardization of maximum usage duration of cartridge filter. No established procedure for proper cleaning of cartridge filter. And no containment procedure for dust collected on filters. To further analyze the problem, we use 4M analysis. For man, standard, allocate manpower to perform 5S. After operation, problem, absenteeism. Action done, provision of backup from other section. Therefore, our judgment,
Not true cause.
for machine, standard must have equipment for proper cleaning of cartridge filter. Problem, overusage of filter, and no machine to be used for cartridge filter cleaning. No action done yet. Therefore, our judgment,
True cause.
for material, standard must have backup cartridge filter. Problem, no available cartridge filter. Action done, establish minimum and maximum stock level at warehouse. Therefore, our judgment,
Not true cause.
for method, standard must have rule for proper cleaning of cartridge filter. Our problem, no established procedure for proper cleaning of cartridge filter, no containment procedure for dust collected on filters, and no established maximum usage duration of filters. No action done yet. Therefore, our judgment,
True cause.
we identified that the machine and method are the true causes.
For our first countermeasure, the team conducted brainstorming for the collaboration of ideas and suggestions. And we found out that there is a machine for cleaning our cartridge filter, but it's too expensive. Therefore, we have decided to make our own design for a vacuum filter cleaner machine. And these are the parts. On the outside, we have the manual air boost slot, the mechanical rotator, the safety door, and the vacuum lid cover. On the inside, we have the cartridge filter, the sock, the panel, and the filter that we use for the dropping of dust. And how it works. So first, manual air blowing of the cartridge filter, manual pumping, the mechanical rotator rod, for the manual rotation of the cartridge filter inside the machine. So in process sequence, first, load the cartridge filter, put empty sock, install 3 pieces filter, and turn on vacuum. During manual air blowing, as we can see, the heavy particles fall down in the sock, while the airborne, the light particles absorbed by the vacuum and trapped by the filter to become filtered air. To maintain the vacuum air intake, once the vacuum cover touches the red spot, it indicates that we need to replace the dirty filter. So what we did is we look for available materials for a vacuum filter cleaner machine. And take note that all materials used were from stock. We also provide job request form approved by the management, and we endorse all the materials to the maintenance section for fabrication. We tested and evaluated our first countermeasure. Looking at the video, the operator conduct manual air blowing, manual pumping of mechanical rotator rod for the manual rotation of the cartridge filter inside the machine for the removal of dust during cleaning process. So for the summary of result, we improved cleaning process cycle time from 8 hours to 1.5 hours. We reduced manpower from 4 to 1. And for the containment of dust from clean filter up to disposal, 80% of it is not properly collected and disposed and mixed with filter. That's why we conducted YY analysis to solve our problem of 50 kilograms of dust collected or mixed with filter. Why? Frequent replacement of filter during cleaning process. Why? Clogged vacuum due to sticking of dust on filter. Why? Filter traps the dust during cleaning process. Why? No separation of dust on filter during cleaning process. Why? No self-cleaning method on the machine to separate dust on filter.
For our second countermeasure, we conducted brainstorming and collaboration of ideas and suggestions. And we decided to improve proper collection by separating dust from filter by using fabric filter. And we came up with the automation of vacuum filter cleaner machine. How it works, we have automatic rotator, automatic clamping, by using 5 with the slot for automatic air blow system. And upon reviewed, fabric filters is already installed to our obsolete vacuum. Looking at the video, filter have capability to clean itself. And based on our research, according to William Bell, the father of dust collector, fabric filters are one of the most efficient and cost-effective types of dust collector. And it can achieve a collection efficiency of more than 99% of very fine particulates. How it works? First, load the cartridge filter, switch on clamp button, Close the safety door. Press the cycle button. As the cycle starts, filter rotating where air blowing. Heavy particles falls on the first containment. The light particles absorb in the vacuum and goes to the second containment. Lastly, on the third containment, air and gas separated until it becomes filtered air. We also reviewed and finalized this schematic diagram. With that, we consulted to the top management for the approval of our second countermeasure. What we did is to look for available materials and take note, all the materials we used were from scrap. We provide job requests and endorse the maintenance for fabrication. We also purchase 5 cartridge filter for replacement in every 3 days of production. We tested and evaluated our second countermeasure. Looking at the video, the operator checked the machine and turned on vacuum. Next, put cartridge filter. Switch on clamp filter. Close the safety door and press the cycle button. As the cycle starts, filter rotating where air blowing. As you can see, the operator trying to open the vacuum to test the vacuum air intake efficiency. For the summary of the result, we reduce cleaning process cycle time from 8 hours to 0.5 hours. For the containment of dust, before, 80% of dust are not properly collected and mixed with filter. After implementation, 100% of dust are properly collected and disposed. By replacing a 5 cartridge filter in every 3 days of production, we increase vacuum air intake efficiency, and therefore, we eliminated all airborne dust in sanding and polishing area. We also eliminate all dust at all in area of finishing building. We increase 5S plus safety of finishing building from 42% average to 91%. We reviewed metal cast metric result from June to August 2019, and we hit the target of 80%. And because of our second countermeasure, 50 kilograms of dust was properly collected and disposed during cleaning of cartridge filter from June to August 2019. Therefore,
Target achieved!
For the standardization, we standardize the dust containment up to disposition. And we also are accredited holders with complete environment documents. We cannot complete our project without standardization and control documents, and now it's implemented.
And for the potential problem analysis, our potential problem workout parts, probable cost, material use are obsolete and recycled. This group formulated and apply a countermeasure, and all of these are provision of spare, August 2019, tool life monitoring, June 2019, machine checking, August 2019, inclusion of preventive maintenance, June 2019, and all of these countermeasures are in charge to the members, and all of the status are done and under monitoring.
For the tangible benefits in terms of productivity, before we cleaned 5 filters in 8 hours, but now we clean 5 filters for 32 minutes. Also for the productivity, we only clean 5 filters, but now we increase filter capacity from 5 to 17 filters. For the cost, before our cartridge filter has 1.3 to 3 months lifespan. After, we hit 6 months lifespan and still in good condition. Also for the cost, before, we use 4 operators to clean our cartridge filter. After, 1 operator is required to clean our cartridge filter. By reducing manpower from 4 to 1, we have a total cost saving of 18,911 for 3 months of implementation. Since we did not purchase a machine with worth 1.2 million pesos, we fabricated filter cleaning machine with a cost of 2,461 pesos. And take note, we return our investment for just 2 weeks. For the safety, 4 operators are at risk. After, operator is safe. Also for the safety, before, all employees at finishing department are at risk to inhale dust. After, all operator at finishing department is now in good condition.
benefits, our members have increased significantly from 5S and safety and implement also the environmental management system. And also our employees become highly motivated. After the implementation and standardization of our project, we improved dust containment and finishing building, which made metal cast preparation a conducive environment to work for. For our next project, 63% low rate of 5S and safety at die casting building. That's all. Thank you.